G'day, my name's Gerry Millar. I'm from the Atlassian incident management team. And today I'm here to tell you about an incident management process that we've developed over 3 years. This process has helped reduce our repeat incidents to a third of what they once were. It's also delivered a consistent time in our reduction in our time to recovery. So we developed this process organically through trial and error over 3 years. And my hope is that you can take from what we've learned and apply it to your own organizations or companies. So specifically, I'm going to cover the control tools that we use to prevent the incident getting out of hand. In addition to that, I'm going to talk about the insights we've gained from metrics, and finally, how we've smoothed the entire process over with the use of automation. So why have a process in the first place? Well, since Atlassian's inception, we've had constant rapid growth. And while this is a lovely problem to have, it causes chaos, right? Just at the best of times. But it really causes chaos when things break. So when I started, there was no real incident management process. So when things broke, there was no real ownership, okay? And as the company got bigger, this became more of a problem. It was hard to find what kind of people we need to get involved in the incident. When we actually did get the right people involved, it was really hard to issue things such as handovers and the like. So you'd have people burning out, trying to fix things. We were unable to communicate to our management team and also our customers. So incident state was largely in people's heads, right? So it was hard to get a ETA, for example, or a nice, concise paragraph of the incident state to our management team like they'd expect. We didn't really have any form of metrics, and without metrics, it's hard to issue temporal comparisons of how we were doing comparatively to a time period before. So you can't ask questions such as, are we doing better than we were a month or a year ago? It's also difficult to ask questions like identifying problem areas, such as where does our root cause, what root cause is causing most of our incidents? Are they issues of scale? Are they hardware faults or whatever? In addition to that, you might want to find out, is this particular team or system causing most of our incidents? And finally, our culture didn't really have a reflective approach on incidents as much as it should have, so we didn't really conduct post-mortems to the level that we should have, okay? So with that in mind, we came up with an overall process. We've got two sub-processes. So the first one is the incident sub-process, and its goal is to reduce time to recovery of when anything breaks. Okay, that's the main goal anyways. In addition to that, we have the post-mortem process, and that sub-process rather, and that is to prevent repeat incidents from occurring again, and thereby reduce the amount of incidents you have in total. So a high-level look at how our process works. An alert fires and then pages an engineer, okay? That engineer then comes online and has two tasks, okay? To diagnose whether the alert was an incident and also assess its severity. If the severity is sufficiently high enough, pages an incident manager who comes online and sets up our control systems. Now these control systems I'm going to talk to you in great detail about. From here, the incident manager's responsibility is to rally the right people into the incident and get things going. From here, we delegate specific roles. So those roles can be what you'd normally expect. You need technical skills such as engineering skills to actually solve the incident. But in addition to that, you need people who can communicate to your management team and to your customers, whether or not that's updating the status page, whether or not that's answering support tickets or whatnot. We also have what I'd call clerical roles. So when we have really big incidents, you need people specifically to manage multiple streams of work. So our incident, when we have big incidents, we don't generally approach it in a serial-like manner where you would, solve one theory, then work on the next. We try and get multiple streams of work to occur. And for that, it's a big managerial overhead. So we have people who just keep track of that, and in addition to that, keep time logs, etc. From that, we work on resolution. Now, it's just one little point there, but that's probably the bulk of our entire process. And finally, I won't go back. In fact, I think I'm going to have to. Sorry. Jittery fingers. Okay, and finally, we have our post-mortem process, which functions as two things. It's there to mitigate the root cause of the incident so we don't see it happen again, but also to improve the process in generally. So, for example, if we found out that a certain team required training and they didn't have it during the incident, an improvement process might be to get that particular team to be trained up on a certain system that they may need to know about. So what's Atlassian's environment like? We didn't start off as a cloud or service-based company. Rather, we started off selling product. So effectively, we'd make our product, you came along and would install it on your own infrastructure, and you were responsible for the uptime, etc. of that service. So we've gone from a product-only company to what we call a cloud-first company. And the reason for that is that's where we've seen the highest level of growth. This has meant we've got a really desperate ecosystem of services. So we have monolithic instances that dog food our product suite, right? Because that's still very important to us. But at the other extreme, we also have systems that run on stateless microservices and some that are a bit in between. We also host our own data centers, but in addition have third parties that look after our data centers, and some of our services reside on a bit of both of these. Maybe they're going into a transition between one of the two, but there's many reasons for that. Add to that, our teams are spread globally. So we don't have the luxury of teams in the one area, okay? So that, for all these disparate systems and teams everywhere, it brings out a need that we need control of our incidents when things break. So here are the control systems that we use. So the first one is our ticket system. So this is a great tool for reporting. This is where we keep all our structured data, such as what's the severity of the incident? Who's the incident manager? Date fields. When was the start of the incident? When was it detected? And when was it resolved? Fantastic for reporting because structured data is easily to run queries on. In addition to that, this is when someone's paged, this is what they look at first, and it's linked. All the other control systems are linked to that. The second is what we call a war room. So people have different names for this, but it's effectively where we get everyone into one group or one area, and you have that face-to-face communication in getting an incident solved. Now, the fantastic thing about a war room is it reduces your time to recovery because of that fast communication. We have to virtualize some of our war rooms, due to the fact that our teams are spread globally, and sometimes we have people in multiple geos working on it. So just one thing about war rooms is what I typically find is it's hard to get them going because when something breaks, the engineer's mindset is to sort of just work on it. It's overall better to break that and get everyone into the one area so we can solve it. Okay, we also have an incident document. Now, this it supports collaborative editing, so we can actually see multiple streams of work in real time, what's actually happening. So this is a great tool to track multiple streams of work and any kind of unstructured data. So I mentioned the ticket was structured data. For long strings, things like time logs, theories of the incident, multiple streams of work, this is what you should use. Now, where it really shines is when you've got multiple theories and multiple streams of work happening at any one given time, you can actually prioritize which change you want to make. Because typically, we don't like to make multiple changes in incidents. You never know what's happened, what's broken. In hindsight, it's always simple, but during the time, you don't. And quite often, there's a number of theories. You want to make those changes sequentially. Finally, we have our group chat. Okay, so this has some other advantages. It's great for logging. Okay, so anytime someone makes a change, we can and talks about it in group chat, we can actually see the time they did it, and that's fantastic for postmortems. In addition, the incident document too is great for postmortems. So that textual log of information is a great resource. This really shines when we want to give out or share textual information, so things such as daemon output, pertinent logs for people to discuss, etc. But one other advantage that it has, which I really think is great, is the fact that you invite people into group chat. So it's a pull mechanism. And when the stakes are high, we usually get all sorts of people just bought into the incident, right? You can't get that level of participation in any other way. So it facilitates communication, at least textually, by pulling people in, and within a short period of time, you've got a lot of people working on that incident, and then they can join the war room if they're the right people. Okay, so I'm just going to go through a case study of how we've used these control systems, but I'll first get some audience participation. If you're just in a standard Etsy directory, or keep it simple, and you're looking at any Linux daemon, right? Apache, postfix, what have you. What would you suspect to be the standard comment character? Yeah. Yeah, hash is pretty much it. So there's some exceptions to that. Sendmail has a really weird one. I've never used Sendmail. But yeah, hash is generally what we would consider. And that's what our brains would see, you know, if you saw a hash in a config file. So I'm sitting there one day, you know, nice Sydney day, and, you know, I'm trying to use a system that I generally use pretty much all the time, okay? And, gee, it doesn't work, and check the internet, it's up, everything's cool, and then I hear the audible equivalent of this. Okay? So all hell's breaking loose, right? Alerts are firing off left, right, and center. Now, I'm happy to say that I wasn't the incident manager on call at this time, so I went and spoke to the incident manager, and he was already on top of it and had created a war room. So to illustrate, I guess, what we do in terms of setting up our control systems, I'm going to go through a real live example, okay? Now, what I'm trying to illustrate here is there is significant investment in terms of setting up your control systems. And it's always at the beginning, which in one way is a really bad spot for it to happen, because that's when A, you don't know what the root cause is, and you know the least, and you're bogged down with all this sort of setup of procedure. So in this scenario, the incident manager's already set up the war room. As per our process, he needs to set up a ticket, sets up video conferencing, because this alert is this problem is definitely affecting teams in other geos. We link the war room, we link the video conference, we set up an incident document, we link that incident document, we set up a channel in group chat. Okay, we link the group chat channel. We invite the people who are in the war room to the group chat. So we really want to kick off that exponential inviting into group chat, because once that happens, it really snowballs and it's fantastic, okay? We link the control systems into the group chat, because some people won't come through the ticket, they won't have been paged, they'll come through group chat, so they need to know where all the other control tools are. Then, just to add an extra spanner in the works, we find out in our war room that our incident document is down for 50% of our people. So internally, Confluence supports collaborative editing, that's what we use. We have third-party backups for all our systems. And in this case, we use Google Docs, okay, which obviously also supports collaborative editing. Okay, from here, we need to then link the external document, copy the document data over, and enforce that one document's used. That's a total of 17 steps, and in this case, we don't know what the root cause is. We don't even know what systems are down, except that there are a lot of them. Okay, so this is typically what a war room looks like. You will get a lot less smiles. People are just smiling for the camera. It's usually lots of stressful faces. And we actually have the right to commandeer any room that we want in our organization. So upper management have given us that right, because we take incidents very seriously. Now, in this particular situation, it was so dire that our CEO and founder walked in and said, "Hey guys, what's going on?" Now, the incident manager at the time was bogged down setting up those control systems that I just mentioned, okay? So the incident manager is best suited at managing the incident and coming up with driving a technical solution, but also communicating with management in proper ways, right? And at this present time, he's bogged down in monkey work, you know, setting all this stuff up. The good news is that these incident control systems are really good, and we achieved peace in 40 minutes, which was fantastic. So what I'm trying to say is, yes, control systems are very labor intensive, but at the same time, they're worth your investment, okay? It's just unfortunate that you need to do them at the start of the incident. Okay, so our incident document allowed us to had people looking for root cause and diagnosing which systems were down and in what ways in a non-serial way. So they were doing them all in unison. And we could ensure that only one change was made at any one given time. We had 50 people in our group chat within 5 minutes, because people just invite. It's sort of like Spitfire. You know, you don't need to really think about it. Maybe this person knows something. Maybe that person knows something. And it was that textual information sharing through group chat that actually led us to the solution to this problem. And it was the war room that facilitated those quick decisions, right? What do we think? Do we think that this is the right way to go? Also, the incident document helped us with our postmortems, and so did the group chat, because you've already got that sort of nice history. Okay, so how do we reduce our time to recover and get the advantages of all these wonderful control systems? Well, the answer we found was automation. Okay, so I mentioned the first thing that a dev or SRE whose page has to come online and diagnose whether an alert is actually an incident, right? So if they raise a high severity ticket now, we now have a microservice that listens to major incidents. What its responsibility is to page an appropriate incident manager. So we have two kinds of incident managers at Atlassian. Ones who are nuanced on specific services, but they're not on 24/7, right? Because we just don't have enough of them. But we also have generalized incident managers. So the microservice will take out all that logic from the engineer, doesn't need to think, oh, should I page this person, that person? It just comes in and says, right, okay, I've got a specialized incident manager, I'll page them. If not, I'll page a generalized one. Whatever the incident manager who gets paged comes online, okay? Now, to get out of that laborious setup incident stage with all our 17 steps, etc., and add additional stress when things go wrong, add to the fact that when you manually edit stuff, you can actually have problems with your URLs and stuff that you link. So we get a bot to do it. They can now press a button called Setup Incident on our ticketing system, and all these things just come up magically, okay? So we've got the incident document, IP conferencing, and group chat, okay? The IP conferencing being our war room, okay? Add to that, just as a little icing on the cake, some of our incidents start off as Sev3 or minor, and then later on we realize that the impact is a lot worse. So we don't have these systems at the time, and generally discussion is on the ticket only. That's the only requirement for a minor incident. So if it's raised, we can now invite any of the people who have been discussing on the ticket into group chat and starting that snowball invite process and getting that dialogue flowing quickly. Okay, so now to the root cause. Okay, so this is the root cause of our case and exactly what actually happened. So hash is the comment character for our bind configs, but it's not the comment character for zone files, okay? So you probably can see where this is going. The root cause occurred 4 days earlier, okay? So someone committed in our Puppet repo, a hash comment into bind, right? That was pushed out to our dev, and then it went past and then was pushed out to prod. Why did nothing bad happen? Because as you can see, it's all green. As part of our setup procedure or our deployment procedure, we would reload bind to digest new configs. What bind actually will do in this scenario when you've got a corrupt zone file, it'll keep the good one in memory and ignore that one. So at this point, we've added a comment. We don't expect that there's any change. And indeed, there was no change, right? So it's just that this is corrupt, everything's up, everything's sweet. Manifestation of the incident. Okay, so one team was trying to add just A records or whatever, and some of them weren't coming up on our mission critical zone file. We thought, oh, okay, maybe zones bind is a little bit balked. Let's issue a restart. And this is where the incident started. We now have bind in a degraded state, which is actually worse than it being down, right? For that particular zone, it's returning NX domains, okay? Which means that the client cache is saying this domain doesn't exist. Add to that, our monitoring is saying, yep, bind's up. Everything's fine. When we do like lookups, everything's coming up. But everything around bind, at least for that mission critical zone file, is down. Okay, so all these things seem so easy in hindsight, but when you don't know and your monitoring and alerting isn't telling you the right things, it's complicated. So this was the innocuous pull request that brought down our systems for 40 minutes. This is it, word for word, okay? This is what we deliberated in the war room as the most likely solution. Okay, that's the pull request. Just one comment. But it's always this sort of stuff that you don't expect. So how do we, and by the way, someone brought that comment up as a potential issue in our group chat, right? Pasting that exact log. So how do we prevent repeat incidents in the future? Well, our process is pretty standardized. The incident manager at the end of the incident looks at things such as our control tools like group chat and group chat and our incident document and drafts up a post-mortem. From there, the team leads then just talk to the incident manager, and discuss on, agree on actions that were going to prevent root cause. That's a must. And ways to improve how we would deal with similar kinds of incidents. Then the incident team implement those fixes. So applying this process to this particular case study, this was what we used to do when we used to push out stuff to Puppet, which would then push it out to bind. We would deploy configs in dev and then reload bind. That hash comment circumvented that check because bind just came up and didn't read the new file. 2 engineers would sign off on each pull request. Again, human brains, they see a hash comment and they don't actually see that that's actually a problem. They just think it's a comment and legal. And then we would check that our builds reported no error, which they didn't. So this was the actions that we came up to prevent similar incidents from occurring. We would syntax check bind and zone files. So there's a binary called name check conf. This isn't actually run on your bind wrappers like your etc initDs, your systemDs, etc. We now check bind logs for error strings, anything that's sort of suspicious. We will halt the build and have engineers look over it. And we would restart bind instead of reload it because we actually want to see problems manifest if they circumvent these 5 checks. Better that it manifests now than some 4 days afterwards, because when they manifest 4 days after, it's confusion. So in this particular incident, the root cause was 4 days later. We'd had multiple pull requests since, and nothing had happened. It only manifested itself 4 days afterwards. And finally, we decided to get completely off bind and get off config files altogether. We now have our new DNS system that we built that uses just REST API calls, and that's all responsible for syntax, highlight checking, etc. So, centralizing metrics. I mentioned, as part of our PIR process, the incident manager and team leads work closely together. And I also mentioned that we didn't really have a culture of doing postmortems that well, right? So now we have automation that pretty much just reminds people politely to keep doing their PIRs, or postmortems rather, and running them through. Okay, so that's just some automation requests to change culture a bit. So our PIR and incident system, it's all in the one ticketing system, and it has things like time to detection, time to recover, did monitoring discover the incident, the root cause. But our SRE ticketing systems, because SRE is naturally a sort of non-centralized model, we have them all distributed around the organization, okay? So how do we get the advantages, I suppose, of letting SREs work with their own systems as they should, but also the data we need. Okay, so we need to amalgamate that together. And in addition, we have one other system called a service catalog, which has things like who the owners of the system are, what team owns it, what individual, what are the service dependencies, etc. So what we ended up doing, so we could actually, I guess, mitigate or report on incidents, and then iterate and improve to identify problem areas, was we consolidated this all together with a bot. So all these completely unique systems are now combined together, and all that information is linked and then kept in a data warehouse, right? So one centralized system, and we've got all the reporting metrics, etc., that we need so we can fix problem areas. So how have we fared over the last 3 years? We've had a 66% reduction in repeat incidents. And by repeat incidents, I mean incidents with the same root cause. So if a system goes down for completely 2 different reasons, we don't consider that a repeat incident. So you might notice that between 2016 and 2017 that there's been a bit of a slump, okay? And the reason for that is architectural reasons. So we have actual architectural limitations in some of the incidents that we get. But I should also mention, though, that even though the incidents are repeated, the improvement actions that we have in our postmortems mean that we heavily mitigate them, even if we don't do it completely. Okay, so when an incident made, of course, an outage, now it's just a degradation. Where it might have been 30 minutes, it's only 2 minutes. Okay, but we still classify them as repeats. We are working hard to implement architectural changes so that this will go down even further. It's just that its architecture always takes the longest. Okay, so this is a line of best fit. Don't get the impression that we actually saw a median time to recover go down nicely. It does go up and down, but for the purpose of this presentation, I've just made it nice, and linear, so we can actually see. So this has helped us, given us considerable reduction in median time to recovery, which is fantastic. Okay. So takeaways. Having an incident process is good because you can direct resources appropriately because you know where your problem areas are. You know if you're improving, and centralizing your metrics makes it even better because you can therefore identify problem areas even more accurately. The incident process has solved a number of problems for us. It's greatly reduced the number of our repeat incidents and thereby reduced the number of total incidents. It's heavily mitigated the ones we're working on eradicating completely too. It's made us super efficient at response and reduced our time to recovery, and automating the regulatory overhead over such a process makes it even better.